that you got coffee with you. Hello, Maria.
Hello.
How are you doing?
Hi.
Very good.
Hello.
All right. So yeah, I just started the broadcasting this feed on YouTube. So if you don't want your comments to be on YouTube or anything, oh,
No, no
Yeah,
problem.
Matthew,
wait a
you
minute.
might want to mute your YouTube.
What? Can you hear me?
Yeah.
Okay, good. All right. Yeah. So we're just gonna wait 10 minutes. So that other people can join, and we'll be starting at 6:30 more or less. Yeah. Wow.
Uh-oh. Sorry
All
about
right.
that.
All right. Yeah. Then probably during the presentation we'll all mute our mics so that we don't get that. But for now it's good.
Matthew, just one
Yes.
question. So when you make me presenter, I just click on screen share, right?
Yes.
Okay. Thanks.
So I'll put you present to everyone. So now, can you just test it now, actually, so that we can see? We
Yeah.
see.
So yeah. So I'll just do a screen share. Wow. What just happened?
All right. Yeah, you're sharing now.
Yeah. But why does it? Why does it?
I had like an Inception screen there.
Yeah. Why does it do that?
So yeah, you've got to share your screen, but then you've got to minimize the Hangout page because otherwise it's gonna share that, and so that's gonna do the
Okay.
infinite loop thing.
Okay.
Is it possible? Is there not an option to select to share, like our studio?
Yes, when you click on screen share, Anshin,
Yeah.
you can if you have your Python notebook or for me my RStudio, I'll
Yeah.
see RStudio in the list. So you can either share your entire screen or
Right.
share one specific thing, specific
Okay.
application.
So let's do the inception bit first, and then I'll just one second.
So yeah, you've got to share your screen, but then you've got to minimize the Hangout page because otherwise it's gonna share that, and so that's gonna do the infinite.
Alexandre, could you mute
So
either the YouTube video? Is there not an option to select the?
Is that
so
okay?
can you now see?
Yes, GitHub.
Okay. GitHub, and then now there's the IPython notebook. I'm assuming the resolution's okay.
Yeah, it's good for me now. It
So
wasn't great at the beginning, but now it's better.
do you see one screen or two screens? Just one
One,
screen. Right? One. Okay.
we see the NB viewer page.
Okay. Great. Okay. Just that, right?
Yes. All right.
Yeah. Okay.
Yeah, I'm gonna leave for 1 second.
Okay.
And
So I'm
I'll
going
be,
to stop. I'm stopping.
okay, good. I'll be back.
Hey. M- no, that was a delay from somewhere. Yeah. Hello? Yeah. Matthew?
Matthew said he had to go for a sec.
Oh, okay.
All right, I'm back. Yeah, I just had to keep my dog busy because otherwise he's going to be quite annoying.
Matteo, so am I not the presenter anymore? Is it back to you?
No, now it's you, so I can remove you.
Yeah.
Oh,
Okay.
I've got an eject, but I think that would... No, okay, stop presenting.
Yeah. Okay. Great.
So now if I go present me and share my screen. All right, so now you should see our studio.
Yeah.
Okay, that's working for everyone. All right, let's wait another couple of minutes, and then I'll start. Well, actually, I'm gonna start the Kaggle page. Yeah, just well, actually, while we're here, everyone in the room, do you have had time to look at the challenge already, or are you fairly new to it, to the Titanic challenge that I'm gonna be talking about?
I looked at it a bit.
Okay.
I also look at it.
All right. Yeah. So I'll go quickly through the presenting it, showing a bit the data, and then going in the detail. Right. And Von, you'll be monitoring everything online? I see. Oh, wow, we've got more people. Hey, Thomas and Robert, how are you doing? Hello?
Sorry,
We're
I was having a bit of trouble with the audio. What were you saying, Matthew?
will you be monitoring the hackpad just in case,
Yes.
and the broadcast if people are putting comments?
Yeah, I'm doing my best to keep up on those the various other.
Yeah, you don't have the easy job. Hey, oh, hey there. I can see that some people are joining and some are dropping. If you're not able to join anymore, you can go on the broadcast. So if you go on the meetup page, there's a link to the broadcast, and so yeah, if the connection to the Hangout doesn't work, yeah, you can just do the broadcast, and then we'll see. All right, so let's. How many people? All right, and so for everyone that's already here, you can add your email address to the Hackpad page. Same thing. The link to the Hackpad is on the meetup page where you're registered. You can add your email here, and if you're interested to go further and continue with the Kaggle challenge after the meetup and during the next month, more or less, we will form small teams that will be working together on this problem, whether in Python, in R, or whatever language that you might be using. Actually, I can also share the link right there so that everyone has it. Everyone that's here. Yes. So if you go in the chat if you open the chat on the right, you're going to be able to join the Hackpad. I see a lot of people on the Hackpad, so maybe you all are already there. All right. So I guess we're good. I'm gonna start now. I guess we've got how many people? Yeah, we don't have much people that can join live. Then everyone's gonna have to go on the broadcast, but that's good. So, well, thank you everyone for joining tonight. I'm Mathieu. I'm the co-organizer of Montreal Data and the R user group. I'm really glad that you're here to join us for this new experiment that we're doing with this meetup today. It's really something that we've never done before, to host an online meetup. And yeah, so I think it's a great experiment. I'm quite excited to see how all of that goes, and if we can collaborate well online, and maybe in the future we'll reproduce that. Next month our meetup will be in person, 100%, but maybe we'll in the following months we'll mix a bit, both online and offline. Yeah, so really the goal of this one meetup is to quickly give you an introduction to machine learning through a Kaggle competition, a very simple competition to start with. And the main goal through that, I'm not going to have enough time to present you all of the tools and go in much detail. Really what I'm going to do is that I'm going to go through all of the steps quite quickly, to give you the tools to go further. And so that's why we're going to then form teams to work together, because you're going to have the basis to build your own model, submit something on Kaggle. And so Kaggle is really nice for that, because you can submit your code, you're directly evaluated online, and you can iterate on that. So really the goal is to have as many people after this meetup run some algorithm themselves, and yeah, go further with that. And hopefully next month we'll keep the beginning of the meeting for presentations. So if some of you form teams and you've got a good model or something that you've learned that you'd like to present, we're going to give you some time at the beginning of the next meetup so that you can present that to everyone. And so last thing, to collaborate, you've got the link to the hackpad both in the chat here and on the meetup page. So if you go down in the useful link on the meetup page, you'll have the hackpad, and you can leave your email address here, and we're going to form teams like that and keep in touch during this month thanks to that. So yes, that's everything I had to say. I'm going to start right now with a bit more details about the challenge that we'll be working on tonight. So first off, Kaggle is this amazing website. If you want to learn about machine learning, statistical computing, predictive analytics, I strongly recommend you to go through the different challenges that they have. We're going to take this first example, the machine learning from disaster, the Titanic, because it's a great example to start. I really like the data that we have here and what we can do with it. So the goal here is to build a prediction model. And so they give you a list of the passenger of the Titanic, and your goal is to predict whether they will survive or they will die based on the training set, based on some data that they're going to give you. So that's the Kaggle page. On the left, you've got you're going to be able to download the data here. What we're interested in is mainly those two, the train set and the test set. So the training set is, well, actually, I'm going to show you in my code here directly. Yes. So I'm going to read my training set there, read my test set also in R. I'm using R because that's what I'm the most comfortable with, but Anshan is going to present quickly then a version of that in Python. So the goal really is to get everyone to collaborate on the tool they're the most comfortable with. So if I look at the data quickly here, I see that I've got this value of survived. So 0 for people that died, 1 for people that survived. Each row corresponds to one person. We even have we even have the name of whoops, 1 second, sorry. Yes, so we have the name of the people. We've got gender, age, if they have siblings, we have the fair. So here we can already understand, we always say children and women first, so we can assume that by looking at female and male, we're gonna be able to predict a better survival rate, right? So let's go in the code to check that. Here, what I'm doing really, oops, one sec. I'm just gonna look at the proportions of people that survived versus people that died, and so we see that only 38% of the people survived. So what Kaggle really basically asks you is to predict this variable of surviving or not on a test set where you don't have the actual response. But here you see that it's a bit unbalanced, right? If my prediction is that 100% of the people die, I will still be right in 61% of the cases, which is better than random. So it's already something to take in consideration. And so really quick, for this first step that I'm going to do, I'm going to go exploring a bit more the data, because really that's really the first step with any, I would say, any machine learning, but also any data work that you would be doing, right? Knowing your data well will help you quite a lot. I'm just going to look if there's any null values, so NAs, just to know that if there are some variables that I must be careful about. So I see that age has 177 NAs, so I will not be using them now in this model, but in the future, if you want to go further and understand how we can use them, still use them and not exclude them of our machine learning model, we can talk about that later on. So then I'm just gonna do a quick table of survival in the rows, and in the columns the gender. So that's what I said before. We would expect that female would survive more, and here we see that, right? Only 81 women died versus 233 that survived, and the male is totally the opposite. So here I'm just going to show that as proportions, right? 74% of female survived. And so same thing, here we can build a first model of saying just if we say that all of the females survive and all of the male die, we will be between 75% and 80%, right? Yeah, sorry, yeah, one sec.
Just a quick
All right.
note, if anybody's watching, sorry, just 1 second. If anybody else is watching on the YouTube video, I just want to make sure that people can actually see the screen. So just, yeah, if you can, send us a comment. But otherwise, Mathieu, keep going.
Yes. All right. Yeah, can you hear me?
Yep.
Yep. Okay, good. So yeah, that gives you an idea that even if you don't run any algorithm, just by using the data itself, you can start understanding the mechanics and even submit a first model to Kaggle. And so now I'll do exactly the same thing, but with a different visualization. So we've got 74% of women that survived and 19% of the male. And this function is nice because I can, just by changing the variables that's on the right of the tilde here, I can visualize different metrics like that. So the P class is if you're from the upper class or from lower classes. And as expected, people from the upper class will survive more than others. So we can see that it's a variable that we would be using. And now if I mix both upper class, classes and gender, we see that female in the upper class rate really high, 97% of them survived, versus male of the lower class that survived only 14% of the time. So this allows us to go through the data, and really that's the first step that you should always do when you're trying to build a predictive model. Really understand your data is the core of it. In the code that you're going to be able to get from GitHub, I've got more visualization. I've just commented them here because we just won't have time to go through that. So yeah, let's go let's run our first model. And actually, that's not the model I wanted to run first, so I'm just going to change that. All right. So yes, so in R, I'm going to run a logistic regression. That's one of the most used classification methods that will take as a parameter. My first variable here is what I want to predict, so if people survive or not, and then after those two variables are the ones that I'm going to use to do my prediction. So as I showed you before, classes and sex might be a good way to predict survival. So I'm going to use that now. The family binomial is just to say that it's a logistic regression, and the data I'm going to run it on my training set because that's where I have where I have the response, right? Because in my test set, obviously Kaggle doesn't give me the right answer. So I just run this one line, and here I go. That's the beauty of R and of multiple languages that would allow you to run those models. In one line, I have my code, my model, and I can run a summary of it to have a good idea of what it is. So they will tell me what it is that I ran, and the coefficients for each of the variables that I used. So we see that sex male, it's creating what we call a dummy variable of like basically if this variable is equal to 0, it means that you're female. If it's 1, you're male. And so we see that it's going to be negative. So basically saying that male have lower chances of surviving, as we saw earlier, and same thing for P class. The higher the number of the class, the less likely you are to survive, but high number means lower class. You've got to remember that, right? 1 is upper class, 3 is lower class. And the good thing about this summary is that I have the significance, I know more or less the p-value, and so the significance of each of the variables that I've been using. And so here I have really small p-values, and R is nice also. It's showing me those 3 stars, so it's basically telling me that it's highly significant, right? So you can use that if you see that the p-value is much higher, then it's going to mean that you shouldn't use this value at all. It's just going to add noise to your model. Now I'm going to run a prediction with this predict function that we have here from R. And so yeah, that's it. I've just run a prediction of my model on all of the training set. And so if I look at what this prediction looks like, here you see for each individual, I'll have a value between 0 and 1, so a percentage chances of survival, basically. So this person here has 91% chances to survive. The thing is that Kaggle, for this competition, asks me to do a choice, right? I can't tell them 90%, even if in most cases that's what your model is gonna give you. Kaggle wants a clear decision, 0 or 1, do they survive or not? So I'm gonna define this cutoff, 0.5, right? If you're more than 50% chance of surviving, then I'm gonna classify you as someone that survived. And so yeah, run this cutoff. And so now if I look at the same thing, head of train predict, I see that I only have 0 and 1s now. And now to evaluate my model, I'm gonna see this table that shows me in the column the actual value, did the person survive or not, and on the rows the predicted value. So the upper left and the lower right are when I was right when I said yes, when I said 0 and the actual was 0, or when I said 1 and the actual was 1. So this allows me to see how many errors I did, and here I also compute the error rate. So here I'm right in 78% of the cases, which is better than random, better than saying that everyone's going to die. And so we see that we're starting to improve, and we can start evaluating our first model here. Now I'm going to run the same predict function, but on the test set. So now that's going to be basically my submission to Kaggle. I'm going to run the same model on my test set and give them the output of what this model gives me. I run it, and then the second line is doing the same thing with the cutoff that I did previously. And I've created for myself a function that's called create submission file that will just create the file itself for me just by giving by giving to the function the training set, the test set, the prediction I did, and the GLM, the model that I've run. So if I open that, if I open this with Notepad, I'm going to see that I'm not going to download that. All right, so for each passenger, I have a prediction of 0 or 1 if they survived or not. So that's what Kaggle uses to evaluate my model. Now I'll go on their website, make a submission. Here I can add my file. I can also add a comment here. And so one of the nice things about the functions that I've used, the create submission file functions, is that it creates another file that's called description. And this description will tell me what was in my model, right? It's going to tell me that it was GLM, so GLM binomial, so logistic regression. It's going to tell me what are the features that I've used. Well, I can add other things in there also. I'm going to submit that, and so now I'm going to have a new error rate, right? I computed the training error rate, which is a bit misleading, right? Because it's how well I did on data where I know the result. So it's in most of the cases, it will be better than on data that I never saw before. So what Kaggle is computing is the error on data that I don't know at all, and that my model doesn't know at all. And so here we can see that this model performed quite well, 76% accuracy in this model. So I can do multiple submissions and see which one was the best. So yeah, next step, I'm going to show you how to improve on that model. So we've already... Yes?
Mathieu,
yes.
Just a quick question. It seems that maybe on the YouTube stream, your screen isn't being promoted for some reason. If you can see there, go back to the Hangout.
Oh.
Yes. So this is what we're seeing on the YouTube stream. Is there a way for you to promote your screen so that it shows? Otherwise, it's audio right now. But
all right, I'm gonna.
Yeah, some kind of.
So if I do entire screen share, so yeah, is it good now? Is it better?
No, it's showing Anshin's profile picture.
All right. Can I?
But the audio is coming through loud and clear, as I understand.
All right. Yeah, I'm really sorry about that. Present to everyone. No, you don't.
Yeah, try this and see what happens.
Oh, is it?
It's strange because.
Can you see it now?
Well, the thing is, it's going to be 30 seconds delayed.
Oh yeah.
So we're not going to know. But if that button wasn't pressed before, then maybe that's.
Yes, maybe that's it.
That's the answer.
Yes, well, I don't know what else to try after that, so we're going to try that.
Yeah, this is part of the experimentation, getting used to the new Google Hangouts format. So
yeah, with the tools. Yeah, we'll get better at it, that's for sure. So,
indeed.
Yes.
Okay.
Yeah, so back to our model. So I showed you how to compute the error rate and also to look at how well did my model perform. So basically, if I run this piece of code again, but with a different model, and I compare the error rate, I would have a first idea of is my new model better than the previous one. But I've got also other ways of doing it. For those of you that have a bit of experience with statistics and machine learning, I'm not going to go through cross-validation right now, which is really simply, in a simple way, it's a way to evaluate error on the that is less biased by the fact that you know the training data, right? Because you're training your model on some data where you have the answer, but the cross-validation will correct a bit for that and give you a better view of what the actual error rate on real data that's outside of what you have already. Yeah, so it would give you a better estimation of the actual error rate. But I can also use other tools like the ANOVA here. So what I'm going to do here, I've got GLM Fit 1 and GLM Fit 2. One is with only the sex feature, and one is with the class. So I'm just going to run both. Here I'm going to do a summary of this one. So we see that we only have the sex male variable here for the first one. If I do a summary of the second one, we have both sex male and P class, and we see that both variables are significant. So they're supposed to help my model. So now if I run an ANOVA on that, what they will do is that you'll see here model 1, my fit 1, my fit 2 in model 2, and a bit the same idea of looking at the significance of the difference between those two models. So the lower the value that I have here, the higher the chances of my model improving with model 2, which makes sense, right? If I add the variable of class, I will be able to improve my model. Yes, so then you can play a bit with all of the variables that you have here. I've been using just a few of them, but you can use also the fare, for example, which is the price of of the ticket that people bought. And so now, if I run this one and I look at the summary, what I see is that my p-value is really, really high, 0.47, and so we don't consider that as significant. So this would potentially lead to more noise than actual better prediction in my code. And yes, so I can add more values. I'm not going to go through too many complex models right now, but you can do this here and compare models one by one, or you can also take the same formula here, add it to my first model that I had up there, and look at the error rate. So see if it improves a bit or not. So we see that here, whoops, sorry. Here it improved to 79%, but you've got to keep in mind that this improvement is only on the training set. It might not, you might not see the same improvement when you submit your model to Kaggle, or when you run this model on real world data. Yes, so that's pretty much what I wanted to present in the on GitHub. You're going to find also a decision tree model. This is a bit of a more complex one, but you can see that it's still one line where you can get all of your model in there. You've got the survived variable, the same model as what we saw before. On the right of this tilde, you've got all of the features that you would be using. And yeah, you can run this fit and basically do more or less the same thing that with the logistic regression model. Once you know how to run one, once you know how to evaluate it, usually it's pretty easy to learn a new one. Obviously, you've got to understand a bit the theory behind each model to know in which case you would use one or the other. I'm not going to go through that right now because that would take us another 2 hours. But so yeah, now I'm going to let Anshan quickly go through his Python code. Right after that, we're going to split into multiple rooms. So what we're going to do is that I'm going to stay in this room and continue working with my R code. If some people are interested in learning more about that, maybe looking at the decision tree, maybe looking a bit more at the data together, you can stay in this room. Otherwise, you can go in the two other rooms. Anshin, I don't have the link to your room actually. If you could add it to the hackpad, that would be great. The room 3, we're gonna have Van in there. That's gonna be also answering question, brainstorming with you if you have any questions to ask. If you want to form a team, you can go in this room and start discussing with people. So really, yeah, the goal here is going to be to share our ideas. How can we make that that model better? So you just have to go on Hackpad. If you go on our meetup page, you're going to have the link in the useful link sessions. You can see all of the links that we have here, and also add your email address so that we can contact you in the future if you want to collaborate with people during the next month and present maybe your model at the next meetup, or just for fun submit something on GitHub and see if you can make it to the top 10% or something. All right, Anshin, I'm going to leave it to you. I'm going to stop sharing my screen. Van, are we good with the broadcast?
Yeah.
Was it showing?
Yeah,
yes?
That's what fixed it.
Okay.
So I guess if you promote Anshin's screen and then press the present to everyone button.
So now you should see Anshin. Anshin, can you share your screen now?
Yeah, can you see it?
I can see it, yes.
Okay. So hi, my name is Anchan. I've prepared an equivalent sort of implementation, so to say, in Python. And what I'd like to do is, Matthew was very good with the presentation and the overview of everything. So the entire goal of this is the demystifying part, I think, comes in when you start working on it. And we want to, we're there to learn and perhaps, go over the theory if necessary, as and when the time comes. But basically the goal of doing all this is a lot of the information is scattered. So how does one even start with playing around with machine learning? So we picked the Titanic challenge because it's organized in some way. So quickly to go over the code on GitHub is that I wasn't sure about everybody's background. So if you're new, so okay, before I come to that, if you're on the Kaggle page, right, on the left under information, you'd see uh, links to getting started with Python. Those are in two parts. And the third one is basically building a model. So I have basically followed those tutorials to do what I've presented or put up on GitHub. So if you read through that, you're in good shape to understand what's going on the GitHub code. So basically, the Python part uses a package, a toolkit called, or a Python module called Pandas. And for the machine learning bit, it uses a machine learning uh, package called scikit-learn. Now, these are both available open source. But in case you are new to all this, I put up some links on what you would need to do for a scientific Python install. And then I've also put up some links to, if you're not familiar with logistic regression. So that's the first model that Matthew talked about. So I've put up a couple of links on logistic regression for classification. And obviously, as Matthew said, you can, once you have your basics working, you can start comparing models and trying to do something a little more sophisticated. So you could use decision trees, or the tutorial on Kaggle itself talks about using random forests. So I've put up an introduction to Python, an introduction to NumPy, an introduction to Pandas, and a few other resources. So there are multiple resources you can find on the Kaggle problem. And one of the main goals is a lot of this information is scattered. So we're trying to just put everything together so that it it's easy for you to start off. So the Python notebook itself basically tries to achieve 5 broad steps. You might find a lot more fancier notebooks out there, but I wanted to give you or give someone starting off a sort of skeletal version of what you might need to do. So a large part, as Matthew said, of any data problem is to clean up the data and perhaps to create new features out of your data. So Matthew said class um, and sex. So basically 91% of the females in the training set survived, right? So you might want to think of creating a combined feature out of those two. So that I would call something called feature engineering. So basically, what this notebook does is it loads all the modules. I use pandas. So pandas has an automatic read CSV function to load it into what is called a data frame, which is pretty much what it looks like in a spreadsheet. So if you go through the notebook, I've used some basic pandas functions like info and describe to get more information about the data. The age field you can see has a lot of null values. So it has about 177 null values. So the decision I'm taking is, or the route I'm taking is to say, how can so you always want to sort of see, do you want to discard a field just because you don't have enough information, or do you want to substitute that field with something with your best guess about it? So these are a lot of the decisions that you'll have to take when you work on a data problem, as to how important a feature is it, or if some things are missing, how do you deal with missing features? So I've used the pandas is null function basically on the data frame to display that there are about 177 entries in the training set that are null. So what I did, and this is following the tutorial online, is that you can replace these age with these null entries with median age values. And basically what I've put into the notebook is calculating median age values for the gender and the P class. So you'd have 6 median age values. So there is some Python code where the trouble with scikit-learn is that it's not compatible with pandas, so it can't take a pandas data frame, which is our main vehicle here to sort of clean up the data and create new features. So what I have done is basically to get the data from pandas and into NumPy. So back to where we were. So once I'm done, uh, uh, so I replace strings with numeric values. So I have to do a lot of sort of substituting here and there. And once I calculate the median values, I basically create a new field. And these are my age entries with non-null values, right? And now this is what I call some feature engineering. Is age times class significant? Now, what you would do is, like what Matthew did, is you could create a new feature called gender times class, right? Or so I go through the machinations of doing that, creating a new variable called family size, and so on, and then I drop values that are strings because NumPy can't deal with strings. So we keep only numeric values. And then I go about using the dot values feature on a data frame to get my data into NumPy. And I basically have oh, sorry, this is the supervision label. So I separate the supervision labels from my training data, which I call NumPy train and NumPy supervision labels. And similar to what you saw, I've imported logistic regression from scikit-learn. So I create the logistic regression object. A lot like the GLM fit you have on the logistic regression object, given your training and test data, you create a model, right? So basically, my final data looks like this, where in under out 112, you could see that um, these are the only numeric fields that I have. So once I've done that, I've created my model. What I do is I'll scroll down, and what I do is at the end, I've done all the equivalent steps for my test set, and I use my logistic regression model to predict the outcomes. And as Matthew had, I had a, a a submission file that I created, which I ended up dropping into here. And once you do that, I ended up getting a score of 74. So that's obviously a lot worse than what Matthew got, not a lot, by about 4%, which perhaps says that the age feature wasn't the greatest thing to do, but these are things that you learn as you play with your data. So that's my spiel. Um, so yeah.
All right. Thanks, Anshin. I think we're gonna take a few minutes if anyone in the room has questions. I know that for people on the broadcast, it's gonna be a bit harder to manage because you could put comments in the YouTube video, but as the feed is delayed by 30 seconds, we might not be able to answer. But yeah, I want to give anyone opportunity to ask questions and more details if you like about the Python or the R code. All right. No questions. I'm just gonna check in my emails if I received anything from our friends on the broadcast.
Yeah, maybe it's a good opportunity to start getting sorted out for the other two rooms, as well as just letting people start conversations about it if they'd like.
Yes. So I'm gonna go back to sharing my screen so to quickly show you on the Hackpad how it works. So I present to everyone and go. All right. So now you'll see my screen. Yes. So if you wanna join us right now for the further conversations about each of the codes and how to build a model, and well, basically any brainstorming about how to improve those features, doing some feature engineering, and well, get better at with our predictions. We're gonna split in 3 rooms that you have here in the useful links. So room 1 is going to be this one we're currently in. I'm going to stay there and continue with the code in R. Anshan with his Python code is going to be in the room 2, where you have the link right there. And Vaughn is going to be in room 3. He knows pretty much anything. You can ask him about R, Python. If you want to do some predictive analytics in Excel, he can do that. Yeah, you didn't pick a language, so you've got everything.
No, I think what I'm going to do is follow along one of the tutorials.
Okay.
That's posted on the Kaggle competition.
Python or R?
Probably R.
All right. Good. Yes. So, yeah. Well, I'm gonna stay in that room. I guess you guys can start getting in. Yeah. Anshan just told me that he started in his room. So, whoops, back here. So yeah, the room 2 is ready. Ivan, I guess you're gonna open yours right now.
Yeah, I have to, so I'm gonna exit. Thank you kindly.
All right. Yeah. Well, thank you, everyone, and we'll be in touch. Don't forget to put your email in the teams there on the Hackpad if you want to form teams and work together during the next month to build a better model. All right. So I'm gonna let you split in multiple rooms. Just give me 1 second. I just need 1 second far from my mic. Hey, I can see that Ari joined. How are you doing?
Good, you guys?
Good, good. So,
Finally, I have internet at home.
wow. Great. So, did you just join or were you
Just
here a bit
joined.
during the
I'm,
presentation?
I'm trying. No, I just joined because I was trying to connect,
Okay.
and I don't know.
All right.
And I was for like 25 minutes over the phone, try to fix the internet.
Oh, that's that's a bit bad. Uh, all right, 1 sec. I've got a question from someone. I'm just gonna ask. All right, I'm just gonna answer that. All right. Yes, so Ari, you missed the presentations, both presentations actually.
Okay.
And yes, and so the goal now we've split into multiple rooms. We've got Marcin, Maria, and Robert that are still here. Are you guys mics on?
Yeah, yeah.
All
Can you
right.
hear me?
Yes, great. All right. So the goal of splitting into multiple rooms was to discuss about how to build a better model. Ari, I guess you already know the Kaggle competition, the Titanic, right?
Yes.
All right. So yeah, in your case, yeah, Maria and Robert, Ari is really good with everything that's machine learning. He applies that at his job every day. So I don't know what are the topics. I've been really quickly through my code. If you have any question or any suggestion, anything you want to share about that,
Okay, I'm going to GitHub right now.
yeah.
I'm just pulling down your code from GitHub as well.
All right. Yeah, you can get the code there. Download it and let me know if there's anything. Yeah, you can run it directly. It should work as advertised.
Sure.
If you don't have some of the libraries that I use here, actually I don't use all of them. Well, you don't need all of them for everything, right? Because data table, I don't think I use the data tables because data table is basically used to manage large amount of data. But in our case, it's not, we don't need it. R part, rattle, R color, brewer, we use it more for the decision tree. And ggplot is visualization. So everything that's not commented doesn't use ggplot because I haven't done any visualization in the presentation. But I have some of the functions that are commented that would use ggplot.
Yeah, that's right. I think I've got most of them anyway.
So you said that you have multiple rooms. This room here is, are you guys working in R or Python?
We're in R.
Okay, let's do R, sir.
So
Cool.
So Anshan is in the room number 2 with his code in Python,
Okay.
and Von is in the last room, and he said he would follow one of the tutorials in R.
Okay, cool.
All right, yeah. So let me know when you're able to run something or when you have something.
Okay, on studio. And are you guys doing a project? Are you guys splitting